Hi folks, welcome back to Operating Clouds webinar. This is going to be part 2, the what are we trying to do? What are we trying to accomplish by operating clouds? So in this session, we're going to do a quick clouds. We're going to talk a little bit more about automation. Really, when we talk about automation, all the things need to be automated. And really, it's a bit of a joke, sort of an internet meme, but it is an important aspect of the concept of operating clouds and what that really means today. And then we're going to talk a little bit about the future. Where's the intent of this entire session? So let's start with a little review. When we talk about operating clouds, we're really talking about the modern method by which application developers want to consume resource and application operations as well. In the last session, a lot of what we talked about was what it means to operate a cloud today. We talked about how operating in the cloud sense really is more about looking at the automation that's happening in the application space and applying that also to the operations environment, the infrastructure that's being operated. We're looking now more at how we accelerate the operations of applications in much the same way that the applications developers have accelerated the development of applications. And really that's the key. I often talk about the ops dev environment versus the dev ops environment, where operations comes first and the development is there to support that, versus the DevOps world where I see development coming first and operations is there to support the development. Both, I think, are very compelling and important aspects of the modern data center environment, the modern cloud services environment. And really, when we talk about operations, we're talking about all of those automated resources. We're talking about the fact that it is no longer possible to be a cloud operator and only consider the compute aspect or the storage aspect or maybe some pieces of the network service. Really, we need to be holistic about our approach to the overall cloud systems and cloud environment. We then also talked a little bit about some of the skills. We're going to talk about this more at the end of this session as well. But really the skills that one now needs to learn in order to operate, not only is it important to understand the basics of the infrastructure, understand how networks work, understand how the compute systems, the virtualization, the containerization of services work, understanding the storage and the storage virtualization environments and the performance and scale of storage. It's no longer enough to just understand any one of those particular areas, but we now need to understand how we automate that resource provisioning, that resource recovery, the debugging and troubleshooting of those resources. So there's a lot that we need to actually understand, or at least to extend our current skill set in order to be proper cloud operators in this day, in this market space as well. Now, in order to take on the challenge of learning all of these different resources, becoming an expert in not just a networking service space or an application scale service space, but the entire data center infrastructure environment, and being able to operate the applications that then sit on top of that environment, there's a lot to learn, but the benefit is also there as well. First off, even if we're talking about public versus private, there's a constant need to support the infrastructure that gets deployed, whether that be your own local infrastructure and you're actually managing from the bare metal all the way through to the application endpoint, or at least the infrastructure API endpoint, or you're just operating services within a third-party cloud environment. The applications developers are focusing more and more on how their applications interact with those services, but not the actual liveliness and understanding and infrastructure of that service. The goal is for an application developer to move to a platform as rapidly as possible, but often that platform is a set of different resources that all have to be operated as well. And so there's this skills gap that exists. Really, the opportunity for an operator that exists today is to understand that middle ground between the application and how the application works and runs and the infrastructure, be that bare metal or a third-party resource and service. And so this is the thing that we're trying to help people understand as we provide education and provide services in that space. This is also potentially a good point for me to talk a little bit about my background in this space. I saw a big change, and I've always worked at the infrastructure services level, be it providing network services at a large networking systems company, or working with companies to actually understand how those services and resources could actually accelerate their business, really looking at it from that higher level perspective. And one of the interesting things that came out of that interaction with both those underlying resources and the business resources that need something to happen in order for their business to work. Often the application is the tool that makes the business run, but it's the infrastructure that supports the application. And many times the applications developers want to basically put the infrastructure on the back burner. It's not critical. You could put it in the public cloud. You could operate it anywhere. But still, wherever that ends up, there still is a need to truly understand how that infrastructure works, how that infrastructure scales, the benefits and models by which one can automate that infrastructure to accelerate the deployment lifecycle that people want. So there's a lot that we as operators can provide to a business. Again, regardless of the actual targeted resource that we're talking about, that layer of operations, even if somebody tries to be 100% DevOps, there still is an operations component. Often we start to see that, at least in its earliest stages, rear its head from the database world versus the application component world, where the folks that start thinking about the databases and thinking about recovery of the databases become a separate team, even in a dev-focused DevOps environment. So basically, there's a data structure resources operations team and a application management infrastructure resource consumption team that starts to grow out of even a small organization that doesn't really have a big enough team to start really separating out into infrastructure operations, platform component operations, and service and application operations. So we see the opportunity there in understanding any of those number of different spaces and becoming the expert in your organization to continue to drive the benefits that can be derived from this class of service. So one of the things that is changing, if we think about one version of the operator's life, it is the classic infrastructure operator that has a pager or has his phone ready to text him at 2 a.m. if anything breaks in the infrastructure, because the infrastructure was fragile. The infrastructure had no way of self-healing. Often when something did happen, it wasn't as easy as just logging into a system and restarting a service. In a sense, you had to actually do a number of manual tests and checks to understand what might have broken to actually create the failure in the system. Sometimes it was application related, sometimes it was infrastructure related, but there were no tools and no methods for understanding that break fix model and how those resources came together. We've also seen the world of work order driven changes. These are things that often end up with maintenance windows, but also have a very slow life cycle. When something needs to change, you get a work order, and days later, finally, the change occurs. This was the past. This was how things used to be. And the worst of that was, of course, the backup and restore world, where if you needed to restore something, often you had to put in a request to an offsite tape backup environment to try to get some tapes back, which 9 times out of 10 were unreadable. So just an awful sort of space to live in, which was very slow, very painful. And that slowness, while not derived specifically from the operations team, was derived from the environment in which we were all operating, caused grief in terms of actually enabling the sorts of capabilities that people wanted, and created sort of a bad taste in most folks' minds about operations. Operations is that slow thing that causes grief rather than that fast thing that helps me get my job done. And yes, there is, of course, the concept of the maintenance window. 3 a.m. on a Saturday, when everybody else is sleeping, you're in the data center trying to fix and resolve resource problems. These things are changing, though. We cannot have these sorts of maintenance windows anymore, especially in a world where everything is always online. There is no time when you can really say, yeah, we're just going to take the site offline for a couple of hours, maybe 3 or 4. We really don't know. We'll see what happens. That's just no longer acceptable. We have to change how we're doing things in order to enable the modern way that people expect to interact with our businesses. So the first thing that's happened is that a lot of what used to trigger a pager alert is now automatable. The ability to capture information about the infrastructure, about applications and how they're running, drive that through effectively a learning system or an expert system sort of systems enablement model allows us to now automate many of the changes that from our beds at 3 a.m. This kind of shift is huge. It is one of the biggest things, the biggest benefits that operators can enable. It still requires operational knowledge. It requires knowledge of how your applications, your systems actually operate. But once you're able to automate these things, the entire system runs more smoothly. And that's really the key. We're trying to figure out how to make things as smooth as possible for our constituents and for our end users. Automating the break fix comes from that pager-based automation. What used to trigger alerts, now those alerts get fed into an expert system that can actually automate the fix for many consistent changes. Things that happen that we know might happen, like a compute node failing or a storage device failing, can often be automatically fixed by forcing a reconvergence in the storage and a distributed storage environment, or migrating workloads that are offline because of the failure of a system onto currently running systems. Automating many of those tasks is a large part of what the pager line has actually created for us operators. The self-serve change The self-service change model is also a major benefit to us as well. Now we have the ability to step back and enable a set of services, possibly with quotas, to allow our users to get access to resources in a more dynamic, rapid fashion. This is huge from the perspective of our ability to keep our customers happy. So the operator no longer becomes the bottleneck to the end user. Instead, the operator is enabling the end user to get their job done. Makes us a hero rather than the enemy. Also, a change that comes mostly from the application space. The applications need to be able to support this kind of a model, changes the whole concept of backup and restore. Often when people talk about backups, they're talking about going to a previous version of a system. Well, with the concept of rollback, roll forward sorts of environments and distributed storage that no longer has quite the number of potential single points of failure in it, it's possible to start thinking about our applications as these dynamic lifecycle services. Instead of having a current running state and a maintenance window to get to the next running state, we roll forward a new set of systems over time, potentially even, and slowly migrate users onto those new environments, or slowly enable those new features as in one way of thinking about how applications are operated. We can actually roll new features out, and if they fail, we can roll back to a current previous running state without having to think of a restore from some backup state. This is incredibly powerful. Now, this doesn't mean that we don't still Now, this doesn't mean that we don't still see benefit in having a backup and a restore model for services. And I think that those kinds of systems are going to be around for quite a while. But the reality is that if we're relying on backup and restore mechanisms, we've basically put a human operator back into the process and broken this ability to potentially automate more and more and more of these services. The real benefit of this rollback, roll forward, self-service, automated break fix is that we can get to a truly dynamic green-blue kind of a migration, roll forward, roll back kind of a migration scenario, where we can have a running state, we can have the next state, we can migrate our users to that next state, and if something fails, we can migrate them back. And that's something that certainly the application environment has to work with you on this, but the operations are the teams that can help make these sorts of changes happen. And more importantly, we need to think about these changes in terms of automation, not in terms of, yes, at 3 a.m. I'm going to go and hit the button that makes the system start to migrate from the green environment to the blue environment or vice versa. No, instead we need to think of this as something that as the application changes occur, we can actually migrate forward to that next generation of environment. So one of the things I said was that we need to consider automating all the things. We need to think of our environment not as a set of resources that we manually manipulate to a consistent state, but rather that we drive to a compliant configuration through state-based tools. This really is the CAPS set of tools, the Chef, Ansible, Puppet, SaltStack systems environment. These are the tools that we're using these days to actually enable that state-based view of our environment. It also drives compliance. One of the things that we still as operators have to consider is that often we're the ones that are held up to ensuring that our infrastructure meets certain compliance requirements. But if we build everything, our network, our storage, our compute infrastructure, our platform resources, based on this concept of state-based compliance rather than configuration modeled compliance, we actually can automate all of the changes in our infrastructure and always have a compliant or at least known changed state. We're never in a situation where we made a change, now we have to go and remember to document that change so that we can stay in compliance. This is huge. Manual changes break systems. Automated changes, unfortunately, also have a mistake envelope. If I automate a failure, I'm going to automate it very well and potentially at a very large scale. So we do have to think about how our changes are being implemented. But one of the nice things is that most of the CAPS tools have methods for actually dealing with failure to change state. If I actually request a different state to occur and the failure happens, as long as I've built my resources around that CAPS tool appropriately, especially for custom resources, I should end up rolling myself back to a known compliant and known functional state rather than leaving the system in an intermediate broken environment. This is one of the things that we as operators need to think of in terms of the development of our operations and compliance systems. And that leads me to my third major point, which is that with automation, we get to ops dev. We get to an operation state that is supported and driven by underlying application development. The application that we're building is our operational state. The DevOps model is the inverse of that. But from an operator's perspective, we really can care about the operations, the ability to make those changes and automate those changes in our environment. In order to do that, we have to automate the state. In order to do that automation, we have to follow a development life cycle. And that really comes down to all of the sorts of things that the DevOps teams always talk about when they start thinking about how they're building their applications. We need to test all the things. So it's not just good enough to automate them and say, look, I've got scripts that do all this automation. I have to prove that my automation creates a consistent state. And the way that I do that is I do that by creating tests. The whole test-driven development systems model is actually an excellent one for us in terms of automating operations because it gives us known compliant, known functional system states as a part of the result of our tests because we're defining what that functionality should look like. The other thing that we need to start thinking about is when we're automating all of the things and we're operating these systems to get to a compliant state, we also should be thinking about that when we do find errors in the system. The first thing that you do if you find an error is you should write a test that describes that error. Because once we've written a test that can describe the error and we can prove that our test fails in our current system test environment, we can now create a change that fixes that error and fixes the test at the same time. This way, our system gets better, gets stronger, gets more robust, and as changes occur, which is commonplace in any system environment, as those changes occur, we have a way of ensuring that our changes are still consistent and aren't recreating the same errors that we had previously through some other means. So this is incredibly powerful. Test really is one of the things that we have to start thinking about. We have to start configuring our systems model and our solutions model based on those testing and capabilities requirements. So operations really does enable cloud. When we start thinking about what cloud really means, most applications developers today especially start talking about how they're going to containerize all their applications and they're going to have to deal with less of the infrastructure because they've containerized it and it's more consistent and runs at any system at any time and any point in place. That's great. However, I'll tell you that operations just enable that through the ability to allow the infrastructure to provide those resources to the application developers. The applications developers, especially the old school sort of first generation DevOps folks, were thinking about this from the soup to nuts model. Let me operate my environment from bare metal all the way through to my application. The problem is that when your application's small, you can probably do that. It's not too hard to think about 1 or 2 or 3 or 4 servers, managing those servers and managing your application. But often an application developer has a model for an application that they want to work on, and if they then have to also think about the infrastructure resources, it's taking away from the time that they're focusing on the application. From a business perspective, this is also a bad idea because it means that your business is not able to accelerate the application features, those things that create your business rapidly. So we need to start thinking about the apps folks as a resource that we are going to support. rather than a resource that is doing the same thing that we're doing. There really is a separation that we're starting to see, especially as people talk about infrastructure services not being the area that they want to support or run or work with, and instead they want to think about platform-based infrastructure and resources. What I find interesting about that, and especially as an operator you should find interesting as well, is that the underlying infrastructure still has to exist. It still has to be operated. And while there are multiple ways that you can go about deploying and managing and creating these different infrastructure environments, it is our job to make sure that whatever that happens to look like, that it stays up and running, that it's consistent, that we're not breaking the applications that are running on top of us because of changes in our infrastructure. We really need to make sure that we create the cloud that the applications users want. And that means that we need to be able to provide them platform services. We need to be able to provide them bare metal resources with GPU acceleration if that's what they need. And in order to do that, we need to operate and automate all of those systems resources. So the DevOps users really need this whole automation and self-service resource model. They need it so that they can automate their tests and make their test cycles run more efficiently. They need this so that they can automate their continuous integration and deployment delivery so that they can actually get their applications out and into the public eye faster. That's what we are here to support. And by doing that, by enabling our own test-driven development cycles, by enabling our own continuous integration and deployment cycles, we can now support the DevOps resources in much the same way that they want to be supported. And that, what I'm trying to say there is that as we see the resources shift, we're seeing this shift from the old school ops environment where everything is slow and ticket driven and has its issues with actually accelerating to the needs of the development cycle. And we are now actually able to implement much the same sets of services against our infrastructure management. The reality is, when you think of infrastructure management at that level, we're talking about applications of our own. We're talking about infrastructure management applications. And those infrastructure management applications directly interact with our infrastructure. They directly operate our infrastructure. And by doing so, we enable the automation and self-service systems that the DevOps folks are looking for. That's great. But we need to start thinking about all these pieces together. One example of an environment where I saw this shift happening from the old school to the new school was really interesting. There was a service provider that was looking at deploying cloud. Now, at the time, cloud really meant infrastructure as a service, basically the ability to provide compute resources in a as a service offering, which really meant a self-service based compute offering. Now, on top of that, there was some underlying storage, there were some underlying network resources that were desired. The environment that this cloud, this automated system was trying to be moved into was actually an old school environment that was not focused on application development. It was not focused on the benefits that that kind of service space could actually provide. Instead, it was looking at keeping things consistent and secure. And often this is the big battleground in enabling operations and enabling the promise of cloud. When there's a resource that thinks that the only way to provide things that are consistent and secure is to go through lengthy review cycles for any potential change to the environment, that breaks the modern method of developing, which is often much faster and at a much higher cycle rate than the previous generation is used to. And the previous generation does not necessarily mean age. It just means thinking about things in the way that we used to build and manage and operate environments. One of the interactions, which was really interesting and actually was the thing that delayed the project the longest, just getting the project started, was the firewall configuration. In an automated environment, an OpenStack example of an environment, the security that the system provides and that the security state that can get created automatically in these environments is driven by the automation of security protocols at the edge of the network. The classic network service model, though, is to provide that security at the core of the network. And where these two different models for automation and operations came together, there was basically a clash of resources. Who was going to provide this system and make it possible to actually deploy an application rapidly and change what IP addresses it was presenting and how those actually got mapped into the upstream resource environment so that you could get access to these services that still existed in the older operations environment, those where you did have to get a change ticket ordered or issued in order to change a port on a firewall to allow you to access a service from a different remote IP address. The end result was a quasi mix of the two sorts of systems. Anything that potentially touched those static, older modeled firewalls had to be static itself. And that meant that when a resource automatically was provisioned, one of the components out of the floating elastic pool of IP addresses that was available on the outbound side of the OpenStack cloud, those resources were automatically locked to that user basically forever. It could be cleaned up over time, but it was a manual garbage collection process effectively to clean up those IP addresses. The benefit, though, was that then you could integrate the automation of self-service. Hey, I can get an IP address whenever I need one. I can then keep that IP address through the cycle of the old school, let me put my ticket in order to get this IP address access to a dedicated resource. So there is a collision of those two worlds, but enabling the automation has enabled a much faster turn for many of the applications that this service provider is providing to its customers. It's managing this cloud not for customer consumption, but for their own engineering consumption. And what we're seeing is that the operations team that has enabled this more dynamic systems environment is continuing to expand, continuing to increase their reach. And it's not just operations, it is really an amalgam of an operations team and the development staff that supports those operable environments, supports the ability to automate the upgrade of the different pieces of the infrastructure middleware, basically the OpenStack service, and get those systems and services deployed. So this is really the promise of cloud. This is the promise of the capabilities of this enablement and enabling automation so that application development happens faster, enabling the ability to interact with other systems, even if those systems are not able to move at the same pace as cloud, but providing ways and methods for those interactions to become efficient and consistent. This is really the power and the promise that we bring to the table. Great. Much like last time, what can you do about it? I think that this is a space that we all realize is very important, and it's all the sort of thing that we can all apply ourselves to. We might be sysadmins or network admins or storage admins today, or we might be just looking to get into this space. But the way that we're actually going to be able to go to that next step is to really start educating ourselves. There are many areas that we need to come up to speed on. Applications, how applications work, how application performance is analyzed, how applications are automatically enabled to deal with errors and failures. If we understand that from a systems perspective, we can then apply that both to our infrastructure, how our infrastructure tools work, but we also then better understand how our application consumers, those that are using our infrastructure resources, are trying to use those resources, so we can provide resource that maps better to what the application community is looking for. From the perspective of compute, we need to understand virtualization, we need to understand containerization, the scheduling of resources into our compute environment, understanding how that impacts our ability to address elasticity and address the scale that people are looking for. We need to understand those resources and capabilities. From the networking perspective, understanding not only the old network models, sort of how firewalls work and how load balancers work and how L2 and L3 forwarding work, but we need to understand the dynamic resource provisioning of things like software-defined networking services. Where can those tools be efficient or more efficient in providing data center resources than the older static-based network service models? How about quality of service? How can we apply that to ensure that we get equal consumption or equally efficient consumption or scale appropriate consumption depending on the actual end user's resources of our network services. On the storage side, we need to understand quality of service for storage. That's one of the things that when we look at any cloud provider is a real key differentiator for the different storage tiers that they provide, the different models for what those storage systems look like. And understanding shared and distributed storage services and models is another key thing that allows us to operate the modern infrastructure of cloud. In order to understand these things, though, it's not enough to just read about them. We have to practice, we have to try, we have to actually build these environments out and really get hands-on understanding of how the pieces actually fit together. I find that often when I read something, I get a certain model and a certain understanding of that technology, but when I actually try to implement and actually turn a service on, that's when I suddenly really start to understand that resource. So practice is really critical. You have to deploy your own versions of these services. In most cases, we can do this all virtually. You can deploy an OpenStack environment on a single virtual machine and actually have all of the components there so that you can understand how they interact and why they interact. You can do the same with a Kubernetes or a Docker systems environment. If you need multiple machines, often you can build small enough VMs that they still will run even on a laptop scale environment so that we can start to understand how the pieces fit together. This is really critical to enabling an operations mindset and an automation of operations mindset, because once I understand how the pieces work, once I understand how the pieces interact, now I can automate them and I can actually develop against them. So there are lots of resources. I point to the OpenStack resources not because I think OpenStack is the one and only answer to cloud, but because it provides a core infrastructure model for how a infrastructure services cloud is actually built. And I think it's one of the best documentation sets on the web today from an open source project that describes how the resources work, how they get configured, how they interact. There's so much information there that it's hard to dive into sometimes, but there is a lot there that you can learn from. There certainly are a lot of how-tos on YouTube. How do you do this? How do you do that? Follow the seminars, potentially, if possible, even follow along the command line resources when they show you how to do something on the command line. There's an infinite amount of information that you can learn from YouTube. Some of it's not as good as others. If you find a good resource, certainly share that with your friends, because those are the real gems out there. There's a set of tutorials from Amazon which talk about how to consume their resources. I haven't actually gone to look recently, but I know Google has a similar sort of thing. IBM Software has a similar sort of thing. DigitalOcean has, I think, one of the best community-driven sets of tutorials and guides for how to do things in a cloud sense. Fantastic set of resources that are out there. And of course, from Cumulus Technologies, we have two resources that I think are really appropriate. One is our 5 Minutes of Cloud series. If you just want to get a quick understanding of one of the latest cloud technologies, we've covered most things compute and networky, and even to a certain extent storagey in the past couple of months, and will continue to do so, trying to highlight the changes that are happening in the cloud space, trying to highlight those resources and capabilities. We also have an education page where we talk about the latest classes that we're releasing. We're releasing new classes on a monthly basis, so please do stop by and have a look there. And of course, if you're in this webinar, you're already registered for our newsletter. Our newsletter provides a weekly update of some of the changes and things that are happening in the cloud community, but also we provide discounts on that link, and basically provide just general information about what's going on in the cloud system space. So this ends our second session. Our third session, we're going to talk a little bit more about some of the education resources that are out there and actually look through what those resources start to look like. What can you actually learn from the education services space to really become a cloud operator?